Hey guys, welcome to another video. So today we're going to start a new series titled Final Questions, right? I get a lot of questions from my students saying, what's the hardest question that you get, in an exam? Well, generally speaking, it's the final question, right? So I thought I'd do a series where I just basically do questions, last question in a trial paper, just to show you what sort of level they're at. So today's question comes from the Baulkham Hills 4-unit extension to trial paper in 2022. It's in the topic of proofs. It's a nice question. Not extremely hard, but like just different, right? So, guys, before I dive in, as always, if you haven't already done so, please subscribe to your channel, tell your friends, and like the video, right? Let's get started. So, final question, Baulkham Hills. Let's have a read. So, if that function where C is positive, okay, and K doesn't equal 0, okay, show that Y has a single stationary point between X equals 0 and C, okay, 2 marks. Show that stationary is max if that, and sorry, green's what I have to prove, right? Blue is fact normally when I highlight minimum of this, and then last but not least, show that that equals that. And that same expression, right? It's great. Okay. Let's do this now. Stationary point. That's the key word there, right? Stationary point. So whenever we see stationary point, differentiate and then solve, right? So let's try to do that. And hopefully there's only one answer, right? It has a singular. So let me zoom in to do this so I can be a little bit neater. Okay. So y equals to, what's the function? Xk plus c minus xk. Is that right? Yeah, okay. So first derivative, bring down the k, minus 1 to the k, plus, now using the chain rule will be a minus, but let's do it formally. So bring down the power, minus 1 to the power multiplied by derivative of the inside. Yeah. So therefore, my derivative, right, is going to be k x k minus 1 minus k c minus x k minus 1. Yep. I'm going to put a box around it, right? Because I'm going to probably need it later on to sort of do max min as well. Right? Okay. Now, so to find stationary points, I set this to 0 and I solve, right? So the 0 and I solve. Okay. Put this guy over to the other side, maybe. So I get this, k minus 1 equals to k c minus x, k minus 1. Delete the k's, right? Constant goes away. So maybe move this guy over, right? So sort of divide it back over here. So you get like c minus x, k minus 1 equals to 1, right? And then sort of put them both inside a bracket. Yeah. K minus 1 equals to 1. Now, given that, now I don't know what, does it say if k's even or odd? It doesn't, right? Because I don't know whether k's even or odd. If it was even, I get plus minus, right? Yeah, so I don't know. So maybe I have to test 2 cases, right? Do you mean like basically if that was even and I sort of k minus 1 rooted, right? It can be plus minus. Do you mean? So, but if it was odd, you don't get one answer. If it's even, it doesn't say, so I'm going to explore both, right? Oh, now, given that, so let's see. So when x over c minus x equals a positive 1, x on c minus x equals a negative 1. Okay, times that up. 2x equals a c. Okay, x equals c on 2. Now, does that work? Let's see, c on 2. C on 2 is between 0 and C, positive. Yeah, I think that works. So I'm hoping the other one doesn't work because I want a singular answer, right? So let's have a look. X equals to minus C minus X. Yeah, the X's cancel out, right? So you get like 0 equals to minus C. No solution. Yeah. So therefore, x equals to c on 2 is the singular stationary point. Actually, technically, they ask me to find a point, in which case I probably need a y value. So there's a singular stationary point. Maybe I'll write. So maybe I'll go y equals to xk plus c minus xk has okay a singular point at x equals c on 2. That's more accurate. Oh, okay, that wasn't too bad, right? Now, so step 2, part 2, show that the stationary point is maximum. If that, okay, minimum is that. So I need second derivative, right? Max min, second derivative. So let's go up here. I guess you can use the table method, but I think for this one, algebraically, makes sense, right? Feels like an algebra question, right? So my first derivative, I'll copy my first derivative. Where's that box? There it is. So that's my first derivative. Put it over here. Place it there. Okay. First derivative of that. So second derivative. Differentiate this again. So k minus 1, x k minus 2, and minus k minus 1, c minus x k minus 2 times by negative 1. Once again, that's a plus, and what I'll do is I'll factorize this out. I'll be that plus. Oops. Let me just check my mathematics. I've done something wrong. No, I haven't. That looks great. Yep, that looks fine. I think. Yep. Okay. Yeah. So therefore, at x equals to c on 2, when the turning point is stationary point, I got the second derivative equals to. So if I sub this into the x value there and there, I sort of get like k minus 1, c on 2, k minus 2, plus that's c on 2 as well, k minus 2. So there's two of them. So therefore, my second derivative is equal to 2 of these. So bring out the 2, k minus 1 times c on 2, k minus 2. Yeah. Okay. Now, given that, the key here is that they want you to prove two cases, right? When k, so the case 1, when k is less than 1. Now, it's also less than 0, also greater than 0, right? Because k in the question itself is always greater than 0, right? So when that's the case, the key aspect here is this bit here, right? Basically, right, depending on the nature of k, because for this one, k is just a power, right? Whether it's like, yeah, if it's between 0 and 1, that's a fraction. If it's greater than, it can be like a positive number, but it's this bit here, right? That's the key part. So if you think about this, right, if I sort of do it off to the side, just to illustrate the concept, right? This guy here, if I had to sketch like y equals to x minus 1, that's like a parabola, right? So it looks like that, between 0 and 1. Now, between 0 and 1, for this case here, that's like this bit here, right? So it's negative, right? That guy's negative. Negative gives a maximum, and that's what I want, right? Yep, perfect. Yeah, so when that, yeah, d squared y dx squared is less than 0, right? Yeah, because since k minus 1 is less than 0. Yeah, therefore, max stationary point at x equals to c on 2 when k is between 1 and 0. Yeah. The other case, when k is greater than 1, right? Now, when k is greater than 1, we're talking about this arm over here, right? This part over here. So then the second derivative is greater than 0 since k minus 1 is greater than 0, right, on that positive arm there. So second derivative greater than 0, therefore minimum stationary point at x equals c on 2 when k is greater than 1. Guys, and that's my answer, right? Unfortunately, it's only for 1 mark, but hey, there it is, right? Is that okay? Part 3. Now, part 3 says prove these two cases out. These, I mean, if you were smart about it, you can sort of see that 0 to k, k is between 0 and 1. That's case number 1. K greater than 1. That's case number 2, right? So somehow I'm going to use this case. Now, the best way to understand the next part, right, is to go, okay, they made me find a maximum or a minimum. How do I use that, right? Now, graphically, just using a parabola to demonstrate, right? If I had a maximum there, right? Let's say my graph. Sorry, let's get a better graph. If I had like something like that, right? And this was max, right? When x, in this case, equals to c on 2. Basically, every other value, right, is going to be smaller than that. Yeah, every other value is going to be smaller than that. So this is how I'm going to play it, right? So I'm going to find the y value first, right, of that maximum, right? So sub the x equals to c on 2 into the equation. So max, sorry, max or min, right? So that's when it's a maximum. The other case is when it's a minimum, right? Same deal, right? You got like x equals to c on 2 there. I have to find the y value, right? So either way, I'm going to sub c on 2 into the equation. So when x equals to c on 2, y equals 2, or c on 2 squared plus c minus x on 2 squared, right? So what's that, guys? That's like 2 c on 2 squared. Yeah, okay. All right. Now, when k is between 1 and 0, right? We know it's a maximum. So it's the first case, right? All the y values, right, are going to be smaller than the maximum. Yeah, all the y values are going to be smaller than the maximum. Yeah, between 0 and 1. So let me see. Yep. Yeah. Now, let me see. For this one, but that, assuming that I can't equal to c on 2, also x can't equal to that, right? Because otherwise it'll be equal. I don't want equal, right? Assuming that, then all the y values, right? So every y, so when I go xk plus c minus xk is always going to be less than the maximum y value, which is this, right? Does that make sense? So any other, except for the stationary point, right? So excluding x equals to c on 2, all the y values in the green highlight there are going to be smaller than maximum, right? All of them. Yeah. Similarly, when k is greater than 1, right, and x can't equal to c on 2, the opposite is true, right? Yeah, every single y value on here is going to be bigger, right? Bigger than the maximum or the minimum, right? xk plus c minus x, k is greater than the maximum. Now, I'm going to strategically substitute things into these two, right, to get what I want now. So look at the thing that you want, right? So I'll zoom out here. See how there's like A and B, right? But it sort of looks sort of similar. I can sort of picture it making sense, right? So for example, let's see, how do I do this, right? If I let's say I let X be A, right? So I'm going to strategically go, okay, what if I let X be A? Now, that gives me my AK. And then how do I get this guy into making it look like B? Maybe I'll call this guy A plus B, because an A plus B minus A gives me B, right? And then this guy here on this side would be A plus B as well. So I'm going to double substitute. I'm going to let X equal to A and let C equal to A plus B, just so I can get AK plus BK, and then see if it actually gives me what I want, right? Let's have a look. So let X equal to A and C equal to A plus B, right? That's the key. Yeah, that's the key. Well, I want to do it in black, right? I want to do it in black, so let's see. Okay. Right. So then you get, now, when K is, when K is between 0 and 1, right? I then have AK, AK plus A plus B minus AK is less than 2 times A plus B on 2 to the power of K, right? Just check that. Ooh. What? Is it squared? That's a K, right? Yeah, I wrote that wrong. That guy there. Oh, that should be a K there. Oh, it's because I wrote it wrong up here. So yeah, that should be K, K, and K. Cool. So I'm subbing stuff into here. I'm subbing A equals to X equals to A and C equals to A plus B, right? Okay. I'm getting this picture, guys, and you can sort of see it's going down the right path because that's BK. Divide that 2 over. Yeah, so I get that. It's less than A plus B on 2. Okay, tick, tick. Yeah, when that case is true, that case is true. And similarly, exact opposite, when K is greater than 1, then AK. In fact, copy and paste exactly the same thing here, right? Let me delete this. Right, I'm just going to be lazy. You guys can do it too. Oh, sorry. I say you guys can do it. If you're copying this down, then you can't, right? But you guys can appreciate it. And then I know that this guy here was greater than, and then greater than. That's what I want. Is that right? Done. Perfect. Guys, how's that for the first of a series, right? That I want to do with final questions. Final questions are good, right? I mean, this question here, normally final questions are designed to waste your time. This one here wasn't too bad. 6 marks, pretty heavy still. I don't think it was particularly hard. It just required you to sort of apply some calculus, stationary points, test maximum, minimum, and a bit of strategic substitution, right, at the end to get you to the end of 6 points, 6 marks. Guys, if you like that, like the video, subscribe to the channel, and tell your friends. I'll see you at the next one. Thank you very much.